In this video, we're going to look at the CSEC Math January 2024, Paper 3. So here we have question 1, Part A. We have the diagram below shows the graph of 3 lines, L1, L2, and L3. So that's be line 1, line 2, and line 3. The shaded region R, so this is our shaded region R here, which represents the common region for the 3 inequalities associated with the lines L1, L2, and L3 that define R. So this shaded region would be the region that satisfies the inequalities associated with line 1, line 2, and line 3. So for part 1 of this question, we have the table below shows the equation of line 3. So we see in line 1, information is missing. Line 2, information is missing. But line 3, we have y is equal to 2 as the equation of the line. And the inequality associated with the line, we have y is greater than or equal to 2. Now let's go back to the next page and look at that. So this is line 3 here. And what we have is a horizontal line touching 2 on the y-axis, which means the equation of this line is y is equal to 2. So for line 3, the equation will be y is equal to 2. Now, if we look at the shading is above line 3. Now, another point to note, line 3 is a solid line. Also, line 1 and line 2 are also solid lines. Now, what's the significance of that? Well, below the line would be less than, and above the line would be more than. Now, since the line is a solid line, below the line would be less than or equal to, and above the line would be more than or equal to. If it was a dotted line, we would just have less than below and more than on top. So since the shading is above the line and the line is solid, we'll have more than or equal to 2. And that's why the inequality associated with the line would be y is more than or equal to 2. So what we have to do is to complete the table above by filling in the missing information for L1 and L2. Write the equations in the form y is equal to mx plus c. So we know m is the gradient and c is the y-intercept. So we know m is the gradient, which is the change in y over the change in x. And we know c is the y-intercept. So now let's go to the page with the graph and fill out the information for line 1 and line 2, both the equations and the inequalities. So now looking at line 1 here, we can see that the y-intercept is 2, and all we need to do is figure out what the gradient is. So I'm going to write for L1, we have the y-intercept is equal to 2, and we have the gradient is the change in y over the change in x. So what I'll need to do is form a triangle on this line that will be more than half the line. So I'll do that right here. So now the vertical distance will be the change in y, and the horizontal distance will be change in x. So let's count the blocks, because each block we're going up by 1 unit on both the y-axis and the x-axis. So if I'm counting the change in y, we're going 1, 2, 3, 4, 5, 6. So that's 6 blocks. So we have the change in y here is equal to 6. And for the change in x, we're counting 1, 2, 3, 4, 5, 6. So the change in x is also equal to 6. Now, the reason I put my change in y as positive is because the line is sloping upwards as we go from left to right, which means we have a positive gradient. So my change in y is positive. In the case of line 2, it's sloping downwards as we go from left to right. See, as we go from left to right, this is going downwards. So line 2 is going to have a negative gradient. So when I do the change in y for line 2, it will be negative. So coming here, we have our change in y is 6 over our change in x is 6, which means my gradient is equal to 1. So now that we have both the gradient and the y-intercept, we can write the equation of the line. So we know the equation of the line is in the form y is equal to mx plus c. So let's fill in the information for the gradient and y-intercept. So y is equal to m, which is 1, x plus c, which is 2. Now, 1x is the same as x, so you can write y is equal to x plus 2. Now for the inequality, if we look at line 1, the shading is below the line. So this way will be above the line and this will be below the line. Again, the line is solid and below is less than. So we're going to have less than or equal to. So we're going to have y is less than or equal to x plus 2. So the inequality would be y is less than or equal to x plus 2. So I could go to the next page and fill out that information for a table. Remember, we have y is equal to x plus 2, and the inequality would be y is less than or equal to x plus 2. So for line 1, y is equal to x plus 2, and my inequality, y is less than or equal to x plus 2. Now let's do the same thing for line 2. Now we can see line 2 touches the y-axis at 8. So the y-intercept for line 2 will be 8. So for L2, we have the y-intercept would be 8. Of course, the gradient would be the change in y over the change in x. So again, we want to form a triangle on this line that would be more than half the line. So I could start about here. And go all the way up here. Again, each block representing 1 unit. So okay, let's count the blocks. So if we count it for a change in y, we count in 1, 2, 3, 4, 5, 6. So now remember this line is sloping downwards, so the gradient will be negative. So I'll put my change in y as negative 6. And now for our change in x, we're just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my change in x is equal to 12. Therefore, my gradient would be the change in y is negative 6 and the change in x is 12. Negative 6 over 12 is negative a half. So m is equal to negative a half or negative 0.5. So writing our equation in the form y is equal to mx plus c, we'll have y is equal to m, which is negative a half, put the x, and now plus c, which is positive 8. So this is the equation of the line. Now let's look at the line and the shading. This is the line and the shading is below the line. Of course, the line is solid. So that's going to be less than or equal to. So my inequality is going to be y is less than or equal to negative a half x plus 8. So now I'm going to go to the next page and fill out this information. So remember the equation will be y is equal to negative a half x plus 8. And inequality will be y is less than or equal to negative a half x plus 8. So I'm going to write here for line 2, y is equal to negative a half x plus 8. That's the equation of the line. And the associated inequality would be y is less than or equal to negative a half x plus 8. So now for part 2 of this question, we have a toy manufacturer makes X phones and Y trucks. The cost to make a phone is $75 and the cost to make a truck is $200. So let's stop right here. So if you're making X phones, X is the number of phones, and Y trucks means Y is the number of trucks. So the total cost to make the phones will be the number of phones times the cost of one phone. So 75 times X or 75X will be a total cost of the phones to manufacture the phones. And $200 for one truck to make one truck. And Y is the number of trucks. So 200 times Y, which is 200Y, will be the total money to manufacture the trucks. So we have the shaded region R in the diagram on page 6. So I just brought the diagram here. So this is the shaded region R we're talking about. Represents the only possible number of toy phones and toy trucks the manufacturer can make. Therefore, the coordinates within the shaded region, the X part of the coordinate represents the number of phones, and the Y part of the coordinate represents the number of trucks. Now, this is a linear programming question. And we know that the vertex of our polygon, a polygon is a closed shape with 3 sides or more. So this triangle is a polygon. And one of the vertex is going to give you the least value and one is going to give you the highest value. So they want us to use the graph to determine the number of phones and the number of trucks, which give the greatest possible total cost of production. So we want the greatest value. And we want to write down this greatest possible total cost of production. So let's get the coordinates of the vertices. So we have this one here. And let's see, this is 4 on the x-axis and 6 on the y. So this is 4, 6. This one here, this would be 0 on the x, but 2 on the y. So this one is 0, 2. And this one here, we have 12 on the x and the 2 on the y. So that's 12 on the x and the 2 on the y. Now, what are we going to do with these vertices? So we come back here to get the cost to manufacture the phones and trucks, which would be x times 75 plus y times 200, as I explained before. So I'm going to put here the cost of production, and that's equal to the cost to make a phone is $75, and the manufacturer makes X phones, so that's 75X. Plus, the cost to make a truck is $200, and the manufacturer makes Y trucks, so that's 200Y. So you're going to put the values of the coordinates for the vertices for the X and the Y here, and see which one gives the greatest value. So I'm going to put using, let's go to the first one, 4, 6. Remember, this is your X and this is your Y. So I'm going to have cost of production is equal to 75X plus 200Y. So that's going to be 75 times X, which is 4, plus 200 times Y, which is 6. And that's equal to, and I'll just work it out quickly on the calculator. So I'll just put 75 times 4, exactly what you're seeing there, plus 200, open brackets, 6, press equal, and we get 1,500. So that's 1,500, and that's $1,500. All right, so I'm out of space here, so I'll go to the next page and continue. All right, so here we are. We already worked out the cost of production for this vertex here with the 4 and 6. So let's go with the 0 and 2. I'm pretty sure this will be the least. So using 0, 2, of course, this is your X and this is your Y. We're going to have the cost of production is equal to 75X plus 200Y. So that's 75 times X, which is 0, plus 200 times Y, which is 2. So you know anything times 0 is 0, so that'll give you 0 here, and 200 times 2 is 400. So that'll just give you $400. So now using the coordinates of the last vertex, which would be the 12, 2, of course, this is your X and this is your Y. We have the cost of production is equal to 75X plus 200Y. So that's 75 times 12 plus 200 times 2. I'll use my calculator for this. So I'll have 75 open brackets 12, that's 75 times 12, plus 200 open brackets 2, that's 200 times 2, and we get 1,300. So that's $1,300. All right, so it's quite obvious that the 4, 6 that we worked out on the other page, which worked out to be $1,500, would be the greatest. Okay, so I just brought it back here on this page for comparison. 1500, 400, 1300. Therefore, 1500 is the greatest total cost of production, and the number of phones would be 4, and the number of trucks would be 6. So if we just come back here as to what the question is asking, using the graph, determine the number of phones and trucks which give the greatest possible total cost of production. Write down this greatest possible total cost of production. So we want the number of phones and the number of trucks, which gives the greatest possible total cost of production. So the number of phones will be 4 and the number of trucks will be 6. After you write down this greatest possible total cost of production, that would be 1500. Alright, so let's put back the part of the question that I'm answering here. And that's going to put number of phones is equal to number of trucks is equal to, and the greatest possible total cost of production is equal to. So let's come back here. Phones is 4, trucks is 6. And the greatest total cost of production will be the 1500. And that's your answer to this question. So now for part B of question 1, we have over time, the company makes a total of 120 toys. Each toy, whether a phone or a truck, is either blue, red, or green. So we have 3 colors, blue, red, or green in color. Other information regarding the toys is as follows. So we have 48 toys are phone, 77 toys are blue, 5 toy trucks are red in color, 36 toys are green, and 4/9 of the green toys are phones. We want to complete the table to show this information. So if you look at this table here, we can see that the total number of toys is 120. That's our total. Here will be the total number of phones, total number of trucks. Here will be the total number of blue toys, total number of red toys, and total number of green toys. So if we say 48 toys are phones, then the total number of phones is 48. So I'm going to put 48 here. If 77 toys are blue, it means the total amount of blue has to be 77. So I'm going to put 77 here. 5 toy trucks are red in color. So we come to trucks, we come to red, and this will be 5 toy trucks are red. We have 36 toys are green. So we come to the total for green, and this will be 36. And now we have 4/9 of the green toys are phones. So 36 toys are green, and 4/9 of the green toys are phones. So we need to find 4/9 of 36 to get how many green phones we have. So I'm just going to work out 4/9 of 36. So 9 into 9 is 1, 9 into 36 is 4, and then we get 4 by 4 is 16. So we have 16 green toys are phones. So we have 16 green phones. So now that we have used all this information, let's fill out what's missing. Now obviously, 48 plus whatever here have to give you 120. So if we say 120 take away 48, we'll get what's missing here. So 120 take away 48 would give us 72. So here would be 72. Next, we have 16 plus whatever is here will give us 36. So 36 take away 16 will give us what's over here. So 36 take away 16 would be 20. So here would be 20. Next, we have 77 plus what's over here plus 36, supposed to give us 120. So if we add the 36 and the 77 and take it away from 120, we will get whatever is here. So if we say 120, take away open brackets, 77 plus 36, and press equal, we get 7. Therefore, here would be 7. Now it's obvious. Something plus 5 is 7, so that something has to be 2. So here will be 2. So these two remain now. So we know this plus 2 plus 16 had to be 48. So obviously 48 take away 2 plus 16 will give it here. Similarly here, 72 take away 5 plus 20 will give you what's here. So we'll have 48 take away 2 plus 16. And that's 30. So here would be 30. And then we'll have 72 take away 5 plus 20. And that will be 47. So here would be 47. And this will be a table completed. So now for part 2 of the question, we have one of the 120 toys is chosen at random. Determine the probability that this toy is a red truck. Now, because it's 120 toys we are talking about, the total possible outcomes will be 120, which is our denominator for probability. And the numerator is going to be the number of toy red trucks. So I'm going to put the number of red trucks is equal to, and if you come here, we have red and truck is here. So we have 5 red trucks. So that'll be 5. And of course, our total possible outcomes would be 120. So now the probability that our toy is a red truck would be 5 out of 120. Now we could break this down using our tables, but remember for this paper you can use a calculator. So you can just put 5 over 120 on a calculator and break it down. So if you go to our calculator and put 5 over 120 and let's press equal, and it gives us the answer in its lowest terms, which is 1 over 24. So that's going to be 1 over 24. We could also express this answer as a decimal by putting 5 divided by 120 and get 0.04166 reoccurring. So we register 3 significant figures. So 1, 2, 3 stop here. After the 6 is a 6. So the 6 will go up by 1 and turn to a 7. So we have 0.0417. So this would bring us to the end of question 1. And now we go to question 2. Now remember, this paper only have 2 questions. So we're halfway there. So now here we have question 2. We have Farmer J owns a triangular field, ABC. So this is a triangular field here, ABC. A scale diagram of this field is shown below. 1 centimeter represents 10 meters. So that means 1 centimeter on the page will represent 10 meters, the actual distance. Now the thing about this question is that I'm on the computer. This diagram, I can scale this to any size I want. As you can see, make it smaller, make it bigger. So this would not be the exact size of the diagram in the actual past paper. So when it comes to A part 1, part A, complete the following statement, which is to get the length of the side of the field AC. Okay, see, the side of the field AC is something meters long. The answer that I'm going to get here would not be the same as the answer that you'll get if you really had the actual paper in front of you and measure the length of the side AC. However, the measure in degrees of the angle ACB, well, it doesn't matter if the diagram is small or big, the size of the angle will be the same regardless. So I'm going to take my ruler. I'm going to put it along the side AC. And as you can see, I put the 0 on the ruler at A. I'm going to take the measurement up here at point C. So if we look here, we have 7. This point here, this little taller stroke here will be 7.5. So each stroke going to be 0.1. So 7.6 and 7.7. So I'm getting 7.7 centimeters. So I'm going to put distance on map is equal to 7.7 centimeters. So the actual distance would be equal to, and remember 1 centimeter is representing 10 meters. Therefore, we're going to take this 7.7 centimeters and multiply it by 10, and we get a distance in meters. So we're going to have 7.7 multiplied by 10. So all we'll have to do is move the decimal point one space to the right. So that will be 77 meters. So the side of the field AC is 77 meters long. So I'm just going to put here 77. Now, when it comes to measuring degrees, the angle ACB, we know the angle is located at the letter in the middle. So the angle is located at C. So AC is an arm of the angle and CB is the other arm of the angle. So AC is one arm and CB is the other arm. So the angle is here at C. So this is the angle we want to measure here. So we're going to take our protractor. So here we have this little stroke here at the center of the protractor lining up with C. Along this arm, we line up with the 0 on the protractor, and that 0 is on the outside scale. So you're going to be using the outside scale and go all the way around to this arm of the angle, which looks like 72 degrees. So if I take this and move it all the way across here to line it up, I'm getting 71.9, which is approximately 72 degrees. So the answer here will be 72 degrees. So here we have to construct the responses of parts 2 and 3 on the scale drawing shown above. Show all construction lines. So for part 2, we have farmer J divides the field with a fence from A. So the fence is coming from A here to the side BC. So a fence from A to the side BC. So this is BC here. And we have each point on the fence is the same distance from AB as from AC. So if this fence is coming across here and each distance is the same from AB as from AC, it simply means to bisect this angle A and draw the bisector touching BC, and that will be a fence. So here I have my compass. I'm going to place my compass at point A, and I'm going to construct the bisector of the angle A. So first we make an arc to cut both arms of the angle, like this. Then where the arc cuts the arm, place the compass point here. Then we make another arc like this. Where the arc cuts the other arm of the angle, place the compass point there. And we're going to make another arc like this. And when we draw a line connecting point A to this point of intersection here, that will be our bisector of the angle A. So this line here will represent our fence. Once we are satisfied with our drawing, we can darken our final outline. So you can see just the line for the fence is darkened and the others remain as light lines. Of course, I forgot to put this addition of the question to part 2, but it's exactly what we did here. So to say using a straight edge, so that's like a ruler, and a compass only, construct the line representing the fence, label the fence AF. So we did that here, we constructed the fence and we had to label it A to F. So I'm just going to put this label here, so we are from A to F, and that's our fence AF. Now we have for part 3, we have farmer J puts another fence along the perpendicular bisector of the side AC. So let's stop right here. This is AC, and we're putting a fence along the perpendicular bisector of AC. So let's construct that. So to construct the perpendicular bisector of AC, we're going to put a compass point at A. We're going to open the compass out to more than half the line AC. If it's less than half the line, it would not work. And we're going to take it and make an arc like this. Then we're going to place the compass point up at C. And we're going to make an arc like this. So now if we draw a line through these 2 points of intersection, we'll get the perpendicular bisector of AC. So this here will be my perpendicular bisector of the side AC. So now that we have done this part, let's continue reading. He decides to keep cows in the region of the field which is closer to AC than to AB and closer to A than to C. So using a ruler and compass only, construct the line representing this fence and shade and label W the region of the field where the cows are kept. So you drew the perpendicular bisector. Now let's darken it to represent the fence. So I'm going to put back the ruler like this, and I'm just going to darken the line representing the fence. So from AC all the way down here. So now let's read this part here. He decides to keep the cows in the region of the field which is closer to AC than to AB. So AC is here and AB is here. So the cows somewhere up here. Either it could be in this region or this region, because this here is closer to AC, this side AC, than to AB. And then we have and closer to A than to C. So it has to be closer to A than to C. So therefore that'll be this region right here. And we are to shade this region and label it as W. So what we could do is put some lines like this to represent the shading. And we could put the W like this, which is the label. So we have labeled the region W and we have shaded the region as well. And this will be the region where the cows will be kept. So next for part B, we have Farmer Massey has a rectangular garden, OPQR, so OPQR, which is shown below. So this is the garden here. We have the length of the garden is 24.5 meters. So that's the length here, 24.5. And its width is 14.15 meters. This is the width here. OQ is a diagonal and OPX is a sector of a circle. So this is the diagonal here from O to Q, and OP to X, this here will be sector of a circle. So if you know a sector of a circle, this here will be the radius of the circle. Here will also be the radius. So these two lengths of side from O to X and O to P will be equal in length, which will be the radius of the sector. Now we have the unshaded sector represents a pond where Farmer Massey stores water to irrigate the farm. So the sector is the unshaded region, so the sector is the pond. The shaded area is planted with crops. So we can see the shaded area here, planted with crops. Now we want to determine the value of the angle POQ. So that's POQ. Let's highlight that. So essentially we want this angle here, POQ. Let's put this as theta. All right, so PO to Q. Now, looking at this, we have a right angle triangle because, you know, the interior angles of a rectangle are all right angles. So right angle here, 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 and of course, the whole angle O is a right angle. So down here is a right angle. So this is a right angle triangle. If this is the length of the rectangle, and here's the width, then here is also the same 14.15 meters. Because the opposite sides of a rectangle are equal in length. So here and here are equal in length, and here and here. So PQ and OR are equal in length, and RQ and OP are equal in length. So I'm just going to put the 14.15 here, meters. So what we have is a right angle triangle here. We know the lengths are two sides, and we want to find a missing angle. So here I am on the next page. I have the original diagram. I just took out this triangle here, OPQ, OPQ. We could have the angle here that we want to find. We have the length of the side here, 14.15 meters. And the length of the side PQ is 24.50 meters. Putting the right angle here to symbolize that this is a right angle triangle. So we know the side opposite the right angle will be the hypotenuse. So if you draw a line from the right angle, it will touch this side here. So therefore, this will be the hypotenuse. We have the side opposite the angle that we want to find, or the angle that's given. Well, this time no angle is given, right? So the angle that we want to find, opposite to this angle, would be the opposite side. So here would be the opposite. And the remaining side would be the adjacent side. So now, in our trig ratio, we only allowed one unknown, and the unknown is going to be angle. I know the trig ratio contains the angle and two sides. So therefore, we need to know the lengths of the two sides. So we know the length of the adjacent and the length of the opposite. So you're going to say so cartois. So ka, twa, and see which one of these has adjacent and opposite. So it's definitely not sine, definitely not ka, this is adjacent and hypotenuse, but twa, tan would be opposite and adjacent. So you're going to come here and put tan my angle theta is equal to opposite over adjacent. So tan my angle is equal to the opposite is 24.5. The 0 after the 5 have no value, so you can just write 24.5 over the adjacent, which is 14.15. And therefore the angle theta is simply going to be the tan inverse of this 24.5 over this 14.15. So theta is going to be, so first we're going to make sure our calculator is on degrees. So we have the DG here symbolizing that the calculator is on degrees. We're going to press second function, then tan. We see tan inverse comes up. We're going to open brackets. And we could either put 24.5 over 14.15 using the fraction button, or we could put 24.5 divided by 14.15. Anyone will do. So I could put 24.5 divided by 14.15 and close the brackets, press equal, and this will be our answer in degrees, which is approximately 60 degrees. If you go to 3 significant figures, 1, 2, 3, stop here. After this 9 is a 9. So therefore this 9 had to go up by 1, which it cannot, which will cause this 9 to go up by 1, which it cannot, which will cause this 5 to go up by 1, which will just be 6, and everything else turn to zeros. So that will be 60 degrees. So what we wanted was the answer for angle POQ to the nearest degree. So angle POQ is equal to 60 degrees. Of course, that's to the nearest degree. Now let's write it here as well. Angle POQ is equal to 60 degrees. Now, this will be the last question on the paper. We want to calculate the area of the farmland that is planted with crops. All right, so let's put in back the diagram here, and we know that this angle here is 60 degrees. Of course, you're going to use pi as 22 over 7. So now, the shaded area is the area planted with crops. So what we have to do is work out the area of the rectangle, because that'll be the total area. Then we need to find the area of the sector and subtract it from the area of the rectangle. So I'm just going to put area of rectangle is equal to length by breadth or length by width. The length is 24.5 and the breadth is 14.15. So this is equal to, so we have 24.5 multiplied by 14.15. So we have 346.675. The answer is exact. So we're going to write exactly this. So we have 346.675 meters squared. Now remember, this is sector here, and OP is the radius, which is the same as OX. And OP has the same length as RQ. So the radius of the sector is 14.15. Let's put that back here, 14.15 meters. So that's going to write radius of the sector is equal to 14.15 meters. So I'm going to put area of sector is equal to the area of a circle, which is pi r squared, multiplied by theta over 360. Now we said that we're using pi as 22 over 7. The radius would be this 14.15. So multiply by 14.15. I'm going to square that. Multiply by theta, which is this 60 degrees here, over 360 degrees. Now, because we have a mix of fractions and decimals, I'll just work this whole thing out on the calculator. Of course, using pi as 22/7 and not 3.142. So I'm going to put equal to. So I'm going to have 22/7. See, I use the fraction button. Multiply by 14.15 and press the x squared button to square it. Multiply by, and I'll put that 60, use the fraction button, over 360. Press equal. And we get, well, this answer is not exact, so we write this to 3 significant figures. So 1, 2, 3. After the 4 is an 8. And therefore this 4 will go up by 1 and turn to 5. But looking at the area that I have for the rectangle, it will be best to write it with the same amount of decimal places and then approximate the final answer to 3 significant figures. So the answer for the area of the rectangle has 3 decimal places. So let's go 1, 2, 3. After this 8 is a 4, so this remains the same. So 104.878. So we have 104.878 meters squared. So now the area of the shaded region will be subtracting these two answers. So area of shaded region will be equal to 346.675 take away 104.878. So we have 346.675 take away 104.878. And that's equal to 241.797. So that's equal to 241.797 meters squared. And now we can write this final answer if we want to 3 significant figures, which would be 242 meters squared. So I'm going to put area planted with crops is equal to 242 meters squared, and that's the 3 significant figures. And that will bring us to the end of this video.